Numbers Systems 7, using properties of exponents. So we're going to work with exponents in this power standard. The first learning target we're going to look at is I can use patterns of positive whole numbers to draw conclusions about properties of negative exponents. So here's the example. 3 to the third power, which we know is 3 times 3 times 3. And if we multiply that, 3 times 3 is 9, times 3 is 27. So 3 to the third power is equivalent to 27. Our goal is to look at patterns and tables, and then actually, as we just look at 3 to the third power, to determine what 3 to the negative third power is. So by the end of this lesson, you should be able to come up with that value. So we're going to start by looking at a table here. We're going to work with the base of 2. So we're going to start with 2 to the fourth power. And we're just going to look at that here. 2 times 2 times 2 times 2. So if we go through the math, 2 times 2 is 4, times 2 is 8, times 2 is 16. So this 2 to the fourth power is equivalent to 16. Now we take 2 times 2 times 3. I'm sorry, 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. And then we take 2 times 2, which is 4. And then when 2 to the first power is just 2. So a couple patterns we're going to start noticing. As we move to the right, so we're going this way, notice that the numbers go 2, 4, 8, 16. And those numbers are doubling, or I could say they're multiplying by 2. So as we move to the right, they're multiplying by 2. So does that mean if we move to the left, would that be the inverse of that? So let's look here. If we go to the left, so 16 divided by 2 is 8, divided by 2 is 4, divided by 2 is 2. So that works too. So when we go to the left, we're dividing by 2, which is going to help us with our patterns here. So since we're not going to the right anymore, because if we wanted to, we could go 2 to the fifth power. And now that we know the pattern, we multiply it by 2, that's going to be 32, and that would be our next column in our table. But we're going to go to the left. And so since we're going to the left, we're going to go down here and look, we're going to divide by 2. So 2 divided by 2 is 1. And if you recall, anything to the 0 power is 1. So it could be 1,000,000 to the 0 power is 1. Or 5 to the 0 power is 1, or 3,253 to the 0 power is 1. And that works in this pattern here. Now if we take 1 and we divide it by 2, and we're going to write everything in fractional form. So 1 divided by 2 is 1/2. Take 1/2 divided by 2. So 1/2 of something, or like a half of a pizza, divide that by 2, you would get 1/4 of that pizza. Then 1/4 divided by 2 is 1/8, and 1/8 divided by 2 is 1/16. So we got all our multiplication and all our division done. We can see patterns. So we learned that if you go to the right, you're going to multiply. And one thing I want to point out is notice you're multiplying by what that base is. So since this base is 2, we multiply by 2. And when we go to the left, we're dividing by 2. Again, by that base number. These two numbers should be inverses of each other, which means opposites. So if you're multiplying by 5, you will divide by 5. If you multiply by 7, you're going to divide by 7. Here's some more patterns I want you to notice. Let's look at 1 and -1. Here's 1. Here's -1. What patterns do you notice? Or 2, -2. 3, -3. 4, -4. So what I'm hoping you notice, we'll start with the 4 here. If this is 16, 2 to the fourth power is 16, notice that 2 to the negative fourth power is 1/16. And 1/16 is a fractional amount. Notice that there's always a 1 in the numerator of all these fractional amounts. 2 to the third was 8. So look over here, 2 to the negative third is 1/8. So let's look at some examples of that now that we can kind of see some patterns. 4 to the third power. So that's 4 times 4 times 4. So 4 times 4 is 16, and 16 times 4, let's do the math really quick over here. 16 times 4, 24, 64. So this is a value of 64. So 4 to the third power is 64. Now looking at my pattern, I can't usually use the table idea of dividing or multiplying since I don't have a full table, but I could make one if I needed to. Or I'm just going to use this pattern that we looked at the end, that if you have a whole number of 64, you're going to put 1 in the numerator, and you're going to notice that that 64 is going to go down in the denominator. Another way to write that, just so you can kind of understand what we're looking at, is 1 4 to the third power. So that exponent goes into the bottom or the denominator of a fraction. You take off the negative, it actually becomes positive, and it's 1. Okay, let's look at 10 to the second power. 10 times 10 is 100. So if we look over here, that would be 1/100th, or 1 and 10 to the second power, 1/100th. Now start to notice as we do this that every time we have a negative fraction, where would that be in a number line? I'm going to ask that later, but kind of start to notice that pattern. Okay, let's do another one here. Let's go 3 to the fourth power. So 3 times 3 times 3 times 3. Well, I know 3 times 3 is 9, times 3 is 27, times 3, we'll do some math here. This would be 21, carry the 2, so that would be 6, 7, 8. So this is 81. So if we look at 3 to the negative fourth power, the opposite, except for the negative side, we're going to go 1 over 81. Or we could write it 1 over 3 to the fourth power. Okay, a couple more examples here. This one, I should have a 5 here. So this is 5 to the fifth power, and I did the math because that takes a little bit of time to get to that number. So 5 to the fifth power is 78,125. And if we go to the negative side of that, we're going to put 1 in the numerator, and then 78,125. Or we could write it 1 over 5 to the fifth power. So as I said, we're going to kind of look at these negative values here. And you can look at it like this, or you can look at it as its actual standard form. The actual standard form here would be these, and the ones below it. And the question is going to be, on a number line, which of the two whole numbers would all negative whole number exponents be located? So if we look at our chart and we kind of look at the negatives we've worked with, and I kind of think about a number line, get one drawn over here to the side, go sideways here, it's a little easier. Where would I put these? Okay, I'm going to mark this 0, I'm going to mark this 1, we'll mark this -1. So if we start to think about, okay, where would we put these values of negative exponents? 1/2 would go approximately here between 0 and 1. 1/4 would be half of that. 1/8, 1/16. So all of right now, all those were between 0 and 1. 1/64th is a very small amount. It's going to be somewhere here. 1/100th, 1/81st. Notice I'm just going to have a bunch of values right here, getting towards 0. Because the bigger the denominator, the actual smaller the number. So 1/100th would be if we would like divide 0 through 1 into hundredths. So like I have 100 of these little dashes, which would be tiny, it would be closer to 0. And notice that we never get a negative value. I could do multiple examples of this, but you're going to notice this never becomes negative. So the question again was, on a number line, between which two whole numbers would all negative whole number exponents be located? it would be located between the whole numbers of 0 and 1. They would never be over 1 because you would always put that fractional amount of 1 over something. But notice they never become below 0 because none of our values are ever negative. They're always 1 something, 1/100th, 1/24th, 1 something. The last thing I just want to summarize this today with is the question of, if the exponent is a negative value, then what do we do? So if the exponent is negative, because that's what we're studying, what do we do? So let's just look at an example here. Let's go 2 to the 6th power, negative 6th power. So a couple things you could do. You could go back to the chart and keep your pattern going and see what we figured out. 2 to the 5th. So remember, going to the right, we multiply. Or we could just figure out what 2 to the 6th power is. And then we're going to put 1 in the numerator. And then we're going to have 2 to the 6th power in the denominator. So 2 to the 6th power. So 2 times 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 2 to the 6th power is 64. So this value is 1/64. So what do I do when my exponent is a negative value? Well, I figure out what the positive amount would be. So in this case, it was 2 to the 6th power, and then I make it a fractional amount by putting 1 in the numerator and whatever the resulting answer is to your positive exponent in the denominator.